We got cut off in the middle of this one. We had just counted 1, 2, 3, 4 down, and 1, 2, 3, 4 across. So the rise is -4, which we knew the slope would be negative because the line's falling. The run is 4, and that means the slope is -1 in simplified form. So our M is -1. Our B is, you can see right there, there's the B, where it crosses the y-axis is 5. So now we can go into y equals mx plus b and plug our numbers in. So y equals -1x, or even better, -x plus 5. So super easy to write an equation. I think there's 2 of these on the final. I made the final last night because someone needs to leave the class early. And I put 2 or 3 of these on the final exam where you have to write the equation from the line. So you find the slope by counting 2 points, then you find your y-intercept, and then you plug those in for m and b. And you could write -1x, like I said, that's okay. I don't know if Alex writes a y equal on it. I think you have to write it all y equals -x plus 5. It won't have the y there. So even better reason to try these next ones because I know E and F are on the final too. So that would be really good to do those on your own. So it looks like we're going by ones. They're just not numbering them all, but we're still going by ones. So starting with the left-hand point, we rise 1, 2, 3, 4, 5. And even though that's not a point, I'm going to use it. 2, oh wait, maybe that's not working. So 1, 2, 3 over 1, 2, 3. 1, 2. Yeah, no, that's not working. So we'll have to use that other point. Huh. That's funny. The graph must not be drawn correctly. So 1, 2, 3, 1, 2, 3. 1, 2, 1, 2. Oh, yeah, because 2 over 2 is 1 as well. 1, 2, 3, 1, 2, 3. Okay, yes, we can use that point. So it scared me for a minute. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we can use that point. So rise 5, run 5, or we could use this point 1, 2, 3 over 1, 2, 3. Both of them are 1, right? 5 over 5 is 1, 3 over 3 is 1. And even if we use this point, we would have had rise 1, 2, 3, run 1, 2, 3, 3 over 3. So it doesn't matter which 2 points you pick, it's going to be 1 again. So rise over run is 5 over 5, or you could say 3 over 3, but it all turns into 1. So M is 1. Whoops, I didn't mean to have that off the screen, sorry. So if we use the big triangle, 5 over 5, if we used these 2 points, it would have been 8 over 8 or 3 over 3. So no matter what, we would have gotten 1 out of that. So it doesn't matter which point you pick. B, or the y-intercept, it crosses the y-axis at 2. So our slope is 1. So our equation putting m in, 1x plus 2, or just x plus 2. Y equals x plus 2. So B is always where it crosses the y-axis, and it crosses at 0, 2. We just pick the y-coordinate. And then these 2 special cases are both on the final and probably both going to be on Chapter 7 test, and they were both on your Module 6 test too. So you've seen these before. So they're special cases because one is a horizontal line and one is a vertical line. So hopefully you memorize from Chapter 6 and the beginning of, I keep saying chapter, Module 6 and the beginning of Module 7 that I can ski on this, but it's 0 fun. I mean, you could do rise over run, rise 0, run 3, 0 over 3, 0, but it's just easier to remember. Whatever trick you have up your sleeve to remember. So you can ski on a flat plane, but it's 0 fun. And we learned that horizontal lines only go through the y-axis, so they're just y equals, and wherever they go through, -7. There's no x in them because they never cross the x-axis. And this vertical one, so I would definitely highlight those two if you're still shaky on them. I know you had them on your last test, but you're going to have them on the next test and on the final two, and you'll see them a lot if you're going into calculus. So those would be good ones to make sure you know. Oh, no skiing here. That means the slope is undefined. And don't write no slope. That's in high school, you're allowed to write no slope. When you're in college, we write undefined. What's the equation? Well, only goes through the x-axis, so that means it only gets an x, just like this one only got a y. There's no x. This one only gets an x because it only passes through the x-axis, and it passes through at 4. So those are super easy. You just have to remember the 0 slope, undefined slope, and then you name them by the axis they pass through. This one only passes through x, and it passes through at 4, so x equals 4. This one only passes through the y-axis. See how all the other ones pass through x and y, x and y. But when they just pass through one axis, that's our special cases, and they just get the letter they pass through. This only goes through the y-axis, and it goes through at -7. Okay, so that is a great page. I think there's at least 4 final exam questions, 4 Module 7 questions on that as well. Okay, because whatever I put on the final, it came from the test. So at least 4 questions off that page. So now we're going to practice writing equations of lines when we don't have a graph. So when we don't have a graph, we have to memorize the point slope formula, which is y minus y sub 1 equals m parentheses x minus x sub 1. And you're probably thinking, oh my gosh, how many formulas can I memorize? Well, guess what? This one is no memorization. Do you know why? It comes from the slope formula. Write the slope formula. M equals y2 minus y sub 1 over x sub 2 minus x sub 1. And remember when we were doing proportions in Module 5, we said that when one side's a fraction, make the other side a fraction and cross multiply. So going across this way, I'd get y sub 2 minus y sub 1 equals, going this way, we get m times x sub 2 minus x sub 1. Take those 2's off, and guess what you have? Ding, ding, ding. Point slope equation. And you're thinking, how can I take those 2's off? Well, what's important is that they're labeled differently. This one has no subscript. This one has a 1. So as long as they're still labeled differently, that's fine. So all you have to do is write your slope formula, put it over 1, write this cross product here, write this cross product here, m times x minus x1, set them equal, and you have point slope. So our original one, let's just write this up here. This one is called slope intercept, what we've been using forever. Slope intercept form is y equals mx plus b, because they're all named by what they give you. So far in this entire class, we've been using this one. It gives us the slope, and it gives us the y-intercept. That's why it's called slope intercept. This one will give us a point, and it'll give us the slope. So the slope will be here, and our x1 and our y1 will be the point. So they all are named by what they give you. This one gives us a slope and y-intercept. This one gives us a slope and a point. That's probably not the y-intercept. So if we're given 2 points, or if we're given a point and a slope, we use this formula. 1 point and a slope we're going to do first. So you take your slope and put it in place of m. You replace your x1 with the x-coordinate of the point and your y1 with the y-coordinate of the point, and then you solve for y. We almost always solve for y because we want it to look like y equals mx plus b when we're done. So once in a while, Alex may ask for another form, but on tests, we always want it in this form, the final answer, y equals mx plus b. So I worked out an example for us to follow these steps. So here is my slope. So this is my m. As the directions say, the x is called my x1 and the y is called my y1. So here's my point slope form. And I'm going to plug m in here. I'm going to plug x1 in here. And I'm going to plug y1 in here. So I call this the plug and chug formula because once you memorize this formula, or not even memorize, are able to derive it using that slope formula like I showed you up here, the rest of it's just plugging and chugging. So let's see what that looks like. So y minus, in place of y1, we put the 4, equals, in place of m, we put 3/5, parentheses, x minus, in place of x1, we're putting, so this is your x1 and your y1. In place of x1, we're putting 1. Then we use our calculator to distribute, or this one you can probably do in your head. 3/5 times x is 3/5 x, minus 3/5 times 1 is 3/5. And then we want the final answer to be in y equals mx plus b form. So that means add 4 here, add 4 here. So I tried to write it like that. I couldn't write it underneath. So y minus 4 plus 4, 3/5 x minus 3/5 plus 4. So obviously on this side they cancel, right? So we get our y, which is our goal. And then on your calculator, you type this in. Let me scoot over a little bit. So negative 3 fraction bar 5 plus 4. And that is 3 2/5, which we have right there. So that's not so bad, right? I mean, the numbers look ugly, but you get to use a calculator, so not bad at all. Okay, so the other situation, so we can use this one when we're given a slope and a point that's not the y-intercept because x isn't 0. We can also use it when we're given 2 points. This one's a little beefier, has an extra step added in because every time I write an equation, I have to have a slope. So if they just give me 2 points, this adds on an extra step. I got to find the slope first. So I still have an x1 and a y1, but I have to find the slope. Then I put my x1, y1 in, and then the rest is the same as the last problem. So it appears to be a little bit longer because it has one step more, because if you're given 2 points, I first have to find the slope. So negative 5 minus 3, second y minus first y, over 4 minus negative 1. So that turns to a positive. So I get negative 8 over 5. And remember, you can write it like this. Usually we type it like that, but when we're writing it by hand, we write it like that. And it doesn't matter. We had that question on our Module 5 test, whether it's out front or up there, all the same. So now we know our slope. I always tell students to label the point x1, y1, the easiest point. So this one, little smaller numbers, so let's call this one our x1 and our y1 since the numbers are a little smaller. I pick smaller numbers and less negatives. So m is negative 8/5, we just found that. x1 is negative 1 and y is 3.